Hey guys, welcome back to video notes here, lesson 21. We're going to be working with slope finally, and we'll call that rate of change a little bit, but it's a ratio that shows how one variable changes with respect to another. So on a linear graph, this is called the slope. It's called the slope of a line. All right, slope is written as a ratio of the vertical change, and sometimes we refer to this vertical change in the rise. So I'm sure you've heard this, rise over something. Hopefully you have. And its slope is written as a ratio of that vertical change to the horizontal change, which we know as the run, between any 2 points on a line. So we could put run right there. All right, so let's go ahead and do one of these rise over run things. See what this is all about. So rise, again, is up and down. We're just simply going to go up, okay? And there's no units to count, but on a graph we would count them. And with run, we're going to run over here. All right, so that's our run, and rise over there. Okay, so this remains constant for any 2 points on the same line. This slope, this rate of change stays constant. And slope is written as a fraction in simplest form. The variable for slope we all know is m. Slope equals m. All right, moving on down, we got 4 types of slope that we can see, and we're going to draw them. So we have a positive. Should have drawn positive in red. Not have done that. So positive, of course, is like this. As x is increasing, y is increasing as well. Let's go ahead and do, beside this one, it only makes sense to do negative, which I, again, should have done with red, but whatever. And we would just have one going downhill. So that slope, or that rate of change, would be negative if it's going downhill. That's a really straight line, of course. I know I'm good at that. Zero slope can occur as well. And that's those weird lines that are just horizontal. That's how that line would look. And then we also have undefined. So we have those undefined ones that go up and down. So finding slope on a graph, m equals, we've already written this, but rise over run. So let's find the slope of each line. And you have to write your answer in simplest form. So I'm going to do one of these. Number 1 only makes sense. So we have a point right there. We do rise first, so let's do that. We're going up 1, 2, 3, 4, 5, 6, 7. So let's go ahead and write 7 for the rise. All right, with run, we're going to be running to the right. Whenever we go right on the number line or on the x-axis, it gets more positive. So we know we're going to be sticking with a positive number here. We're running right. 1, 2, 3, 4. 7 over 4. And can this be simplified? No, it cannot. So 7 over 4 is the answer. So you guys go ahead and try number 2 on your own and see if you can come up with the slope. All right, so I'm gonna rise first. 1, 2, 3. So let's go ahead and put that 3. When we go up, that's a positive 3. And let's go do our run. So we're running left this time. And when we go from positive 1 to 0 to negative 1, that's going a negative direction. So we're going over 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going left 9, so it's coming up negative 9. And this can be simplified to negative 1 over 3 for your slope. All right, 3 and 4 are kind of right there, but let's see. Do we rise at all? Nope. Let's run though. We have to run. So I'm not going to put, let's just go and put 0 for the rise since we didn't rise any. And we're going to run to the right, so it's going to be positive. 1, 2, 3, 4. 0 over 4. Well, anytime we have this 0 as a numerator, we know it's going to be 0. So that's 0 slope, which of course is your answer. Number 4. All we're doing is rising. We're going up 1, 2, 3, 4, 5. So that's our rise on top. And are we running anywhere? Doesn't look like it. We've got to stay right here. So 5 over 0, anytime 0 is on the bottom, that would be undefined. So you have to know how to write this undefined slope. And it kind of makes sense because when it's flat, you have 0 slope, you have no steepness, and when it's undefined, you have all of this. So we can't define how steep. It's just straight up.